Hey, Math 20-2s. Today we're going to look at some trigonometry review of grade 10 trig. So let's consider the right angle triangle AOB as shown to the right. Let angle AOB equal x degrees. Each of the sides of the triangle is given a special name relative to the angle of x degrees. The longest side OB is called the hypotenuse. That would be right here. The sides remaining in the triangle are called opposite and adjacent. Obviously the side opposite x is AB, and the side adjacent to x then would be OA. Recall the definitions of the three primary trig ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. We've got this little acronym to help you remember that. So example 1. Mark on each of these triangles the hypotenuse, the opposite, and the adjacent side relative to angles x and y. Step 1, before we do that, let's recall how to label a triangle. Angles are always capital letters, so D, E, and F. Sides are lowercase letters, so opposite angle D is little d, opposite angle E is little e, and opposite angle F is little f. Same thing in triangle B, over here, triangle STV. Opposite T is little t, opposite V is little v, and opposite S is lowercase s. Now let's label them opposite, adjacent, and hypotenuse based on the angle of reference. So in this first triangle, the angle of reference is x. So the sine of x degrees is opposite F over hypotenuse D. The cosine of x is adjacent E over hypotenuse D. The tangent of x is opposite side F over adjacent E. If we look at triangle STV from y degrees, that's our reference angle. The sine is opposite over hypotenuse, so opposite is T, hypotenuse is S. Cosine of y is adjacent V over opposite S, over hypotenuse S. And tangent of y is opposite T over adjacent V. Next page. In solving problems in right triangle trigonometry, we need to be given a right angle, a side length, and one other piece of information. So we need to have a right angle, one side, and one other piece of information. So another angle or another side. Note the following points emphasized in the right triangle diagrams below. The opposite and adjacent sides can switch depending on the angle being used, so whichever angle we're referring to. And the Pythagorean theorem can be used if two sides of the triangle are known and we're required to find the third side. Okay, so if we're looking from angle A, opposite over hypotenuse is sine, adjacent over hypotenuse is cosine, and opposite over adjacent is tangent. If we're looking from angle B, the ratios stay the same, but the sides relative to the triangle will be different. All right, and here we've got Pythagorean theorem. So we can use all that information. So example 2. Consider the following triangle. Use Pythagoras' theorem to solve and find the length of ST, or little r. That's opposite angle r, lowercase r. So Pythagorean theorem says a squared plus b squared equals c squared. Let's substitute the things in this triangle that we know. We know the hypotenuse is 25. That always goes where c is. So 25 squared is going to equal the square on the other two sides. So a squared is 7 and b squared will be r. So 7 squared plus r squared is 25 squared. If I want to solve for r, then I'm going to minus 7 squared from both sides, and then I'm going to take the square root of all that. All right, so get out your calculators and figure that out. Let's try it. So the square root of 25 squared minus 7 squared. There's our side, 24. All right. So little r is 24. Now, state as a rational number we know are fractions, the values of the following trig ratios. So the sine of angle R. So from angle R, sine is opposite over hypotenuse. So that's R over 25. We just found R to be 24, so that's 24 over 25. Cosine of angle R is adjacent over hypotenuse, so adjacent side is 7, hypotenuse is 25. And tangent of R is opposite over adjacent, so it would be R, which is 24, over adjacent, which is 7. Same thing for sine of angle S. So from S, opposite is 7, adjacent is 20, or hypotenuse is 25. Cosine is adjacent over hypotenuse, so adjacent is R. R is 24, and hypotenuse is 25. And tangent of S is opposite over adjacent. Opposite of S is 7. Adjacent to S is R, which is 24. Comment on any relationships we see in our answers in B. Well, a couple things we should notice. The cosine of R is the same as the sine of R is the same as the cosine of S. And the sine of S is the same as the cosine of R. They're the same ratios. All right, so we can write that down. Sine of R is equal to the cosine of S. We notice that the sine of S is equal to the cosine of angle R. And we also know that these two ratios, tangent of R and tangent of S, are, what's a special name when they flip numerators and denominators? They're called reciprocals. Great, let's move on to calculating angles in right triangles. So complete the following example to review how to calculate an angle measure using primary trig. All right. In the diagram, we are required to determine the measure of the angle marked x. So that's down here. To the nearest degree. So always read what they're asking for. Relative to angle x, we're given the opposite side, which is 6, and we're given the adjacent side, which is 5. We write the tangent of x degrees, then it would be opposite over adjacent, so 6 over 5, or the tangent of x is 1.2. Now you don't have to leave it as 1.2, you can just leave it as a fraction 6 over 5. To find the measure of angle x then, we can determine this by using the inverse tangent function on our calculator. All right, so that's going second function tangent, and then we would just type into our calculator 6 over 5. All right, so let's do that on the calculators. Second function tangent, 6 divided by 5. And if you don't get this answer, 0.87, or if you do get that answer, then your mode's in the wrong value. If your mode's in radian measure, as this calculator is, you're going to get a measure that doesn't make sense. We want to measure in degrees. So hit your mode button, go down until the degree is highlighted, and press enter. So again, hit your mode button, go down until you get to the degrees, and then you hit enter, and that should be now highlighted. Now go second quit. And if I want to do this again, second function tangent of 6 divided by 5, here's what we should get. This is an angle measure, 50.2 degrees. Now the question asked us to find it to the nearest degree. So x is 51 degrees, right? If we look, x is, 50 degrees, 50.1, so 50 is fine to the nearest degree. Example 3. A telephone pole is 12 meters high and supported by a wire of 14 meters long. Fixed to the top of the pole and to the ground. Draw a sketch to illustrate the information, and then calculate to the nearest degree the angle between the wire and the ground. So we've got a telephone pole. Here's our telephone pole. It is 12 meters high, and we've got a support wire fixed to the top of the pole and to the ground. And that support wire is 14 meters long. So there's our diagram. Here's the ground. We're going to make the assumption that the ground and the telephone pole meet at 90 degrees. If we don't make that assumption, we can't do this question. We're asked to calculate the angle between the wire and the ground. So I'm going to call this angle X degrees. The angle between the wire and the ground. That's what we're looking for. Let's go to our primary trig ratios then and decide which trig ratio to use. From our reference angle, I'm given the opposite side and I'm given the hypotenuse. So what trig ratio uses opposite and hypotenuse? Hopefully you said sine. So the sine of an angle is opposite 12 over hypotenuse 14. How do I find the measure of that angle? We just learned that. We go to our calculators and we go second function sine 12 divided by 14. So second function sine 12 divided by 14. I only need one bracket there, and we come up with 58.99. So to the nearest degree, that's 59 degrees. All right. Excellent. Next page. Calculating sides in a right triangle. All right. Complete the following examples to review how to calculate a side using primary trig ratios, sine, cosine, and tangent. The diagram we require to determine the measure of side BC, we could call that side little x as a variable. If I want to label it using triangle labeling, that would be little side A. So from 49 degrees, which is the measure we're given, we're looking for the side opposite, and we're given the hypotenuse. That's why we're going to use the sine ratio. So sine of 49 is opposite over hypotenuse. We're going to cross multiply to get this equation, but really, if I look what's happening, x is being divided by 17.6. The opposite of that is multiplying both sides by 17.6. So 17.6 times the sine of 49. That's what we're going to do in our calculators. So let's try that. 17.6 times the sine of 49. And the measure of x is 13.28. It wants it to 1 decimal. It says, what's the measure to 1 decimal? So that is 13.3. X is 13.3, so length of BC is 13.3. In the diagram, we are required to determine the measure of side QR. Relative to the angle given, 73 degrees, QR, they labeled as little a, I'd like to label it as little p. All right, so I say this is little side P, opposite angle P. And cosine of 73 degrees would be adjacent 24 over hypotenuse P. So P times the cosine of 73 should equal 24, multiply both sides by P, and then divide both sides by the cosine of 73 degrees. So little p, or the hypotenuse, is going to equal 24 divided by the cosine of 73. So let's try that. 24 divided by the cosine of 73. Divided by cosine of 73. And we get 82. So to 1 decimal place, 82.1. 82.1. So side QR is 82.1. So let's use some trig ratios to determine the lengths of AB and AC in the given triangle. So AB is a little c and AC is a little b. So let's use that notation to figure out those lengths. It makes life a little easier. Notice we've got a reference angle of 74 degrees, and we're given the side adjacent to 74. That's 109 feet. So if I want to find little c, which happens to be the opposite side, what trig ratio uses opposite and adjacent? So hopefully you said tangent. So the tangent of our reference angle, 74 degrees, should equal opposite c over adjacent 109. So to solve that, we would multiply both sides by 109. 109 times the tangent is 74 degrees. Will give us C. So do that on your calculator. Here's what it should look like. 109 times tangent 74. We come up with 380.128. Correct the nearest foot. So to the nearest foot, this is 380 feet. So C is 380 feet. All right. You guys try to find the length of side B on your own. Give it a go, and then have a look up here and see what I did. So pause it. All right, so what you should have said is the cosine of 74 degrees. So from 74, I've got the adjacent side. I'm looking for the hypotenuse. So the cosine of 74 is adjacent, 109 over hypotenuse B. To solve for an unknown in the denominator, we multiply both sides by B, and then we divide both sides by cosine of 74. So B is 109 divided by the cosine of 74. If you check your calculator, 109 divided by cosine of 74 is 395. So to the nearest foot, 395 feet. Awesome. Let's go to page 155 and look at the last example. Example 5. A large tree is being transported to a new location. The tree is held vertical by means of two guy wires of unequal length on opposite sides of the tree. One of the wires makes an angle of 48 degrees to the ground, the other wire is 12 meters long and makes an angle of 56 degrees with the ground. Both wires are attached 3 meters from the top of the tree. A, let's illustrate this scenario below. All right, so let's illustrate this scenario. We got two guy wires that are both attached 3 meters from the top of the tree. So from here to here is 3 meters. One guy wire is shorter than the other one. So one guy wire makes an angle of 48 degrees with the ground. So we'll say that's 48 degrees. The other guy wire makes a larger angle, 56 degrees with the ground, and it's 12 meters long. So this is a larger angle, 56 degrees, and this is 12 meters long. So I've illustrated this scenario. Part B, determine the height of the tree to one decimal place. So we're going to say the tree is growing vertically up from the ground, a right angle. That's the same on both sides. Let's find this measurement here, x, which will help us determine the height of the tree. So we are given a reference angle of 56 degrees. I'm just told I want to find the side opposite, and I know the hypotenuse. So what trig ratio is opposite and hypotenuse? Trig ratio using opposite and hypotenuse is the sine ratio. So the sine of an angle, our reference angle is 56 degrees, equals opposite over hypotenuse. All right. Let's solve that equation for x. Go to our calculator, and that'll be 12 times the sine of 56. So 12 times the sine of 56. That gives us 9.948. Now, I said we always want to keep our answers, so let's store this as variable x, so we won't lose it. So that's going to be 9.9 every time I type x in my calculator. So in my notes, I'm going to write 9.9 meters. Now, what's the height of the tree? The question asks us to find the height of the tree. I found x, but that height is 3 meters from the top of the tree. So the tree is 9.9 plus 3, or 12.9 meters tall. All right. Part C asks us to determine the length of the other guy wire to the nearest tenth of a meter. So I'm going to call this measure y, and we're asked to find the length of that wire. So we're given this reference angle, 48 degrees. I just found x, which is opposite, and I'm looking for y, which is hypotenuse. So again, what trig ratio uses opposite and hypotenuse? Again, the sine ratio. So the sine of 48 degrees equals opposite side. We just figured x to be 9.9 over the hypotenuse, which is y. Now how do I solve for y in this equation? I'm going to write that out. Y and the sine of 48 simply switch places. So 9.9 divided by the sine of 48 will give me the measure of y. So y to the nearest tenth of a meter, calculator work. So 9.9 divided by the sine of 48. But I've got that whole measure in my calculator as x. So x divided by the sine of 48. That way I keep all the decimals and I don't round. So side y, or guy wire y, is 13.4. Nearest tenth of a meter, 13.4 meters. Part D, determine the nearest tenth of a meter, the horizontal distance at ground level between the two guy wires. All right, so let's find these two distances, A and B. All right, so A is from here to here, B is from here to here. Then I can find the distance between those two by adding A to B. So in my first triangle on the left, if I want to solve for A, from my reference angle of 48 degrees, it doesn't matter which side I look at because I had to find both the opposite side x and the hypotenuse y. But I'm looking for the adjacent side. So from 48 degrees, adjacent is A, hypotenuse is y. Cosine might be a good one to use. So let's say the cosine of 48 degrees equals adjacent side A over the hypotenuse y. We just found that to be 13.4. So how do I solve for that? Well, to find A, I would say 13.4 times the cosine of 48 degrees. So that's calculator work. So let's do that. 13.4 times the cosine of 48. Again, I've got the value of 13.4 in my calculator. It's already there. So I just have to go times, the previous answer will show up if I just press the times button, and we're looking to say times the cosine of 48, times the cosine of 48 degrees. So now we've kept all the decimals from the previous calculation. We're not rounding anything, so we're going to be more accurate. So that length is 8.957. Again, it probably wants it to the nearest tenth of a meter. Nearest tenth of a meter is 9.0. All right. So A is 9.0 meters. But let's keep that in our calculators. I don't want to round yet, so I'm going to store this. Hit your alpha button. Notice the A cursor shows up, and now right below that is the A on the math. So I'm going to store that answer to alpha A, keeping all my decimals. Let's find the length of B now. So in the second triangle, from 56 degrees, I'm looking for the adjacent side. I'm given the hypotenuse. So once again, I'm going to use the cosine ratio. Cosine of 56 degrees equals adjacent. We're looking for side B. We're given the hypotenuse, which is 12. So let's find side B. 12 times the cosine of 56. You can write that down, or you just know that's going to happen. I'm multiplying both sides by 12. So 12 times the cosine of 56. That gives us 6.7. I'm going to store that as alpha B. So 6.7. So B is 6.7 meters. Now answer the question, how far the two guy wires, what's the distance between the two guy wires? So I'm going to add those two values. The guy wires are 9 plus 6.7. But let's be careful. Let's make sure that's correct by using our non-rounded decimal values. A plus B. So 9 plus 6.7 is 15.7. This is 15.667. So rounded to one decimal is 15.7. So they are 15.7 meters apart. Beautiful. And Part E. Last question. The guy wire in C breaks, and a new wire of the same length is attached 2 meters down from the top of the tree. Calculate to the nearest degree the angle which the guy wire makes with the ground. The guy wire in C breaks. So if you go back up to C, notice that that was side Y. So in C, we were looking for Y. So this guy wire breaks, and it's attached 2 meters further down. All right, 2 meters from the top of the tree. So instead of 3 meters, it's attached 2 meters down. So now that's 2 meters from the top. All right, so let's recreate this diagram now. And it's attached here, and same length, so the length is still 13.4 meters, but it's not going to be able to reach all the way there now. So this length is now still 13.4 meters, but there's a new angle developed here. All right. Let's redraw that triangle in part E then. So I've got this distance, which is 13.4. I'm not sure what this angle is. That's what we're looking for. Calculate the angle the guy wire makes with the ground. So I'm going to call that x degrees. And I do know this distance here. If I think a little bit about it, the top of the tree from the guy wire is 2 meters. And we found the height of the tree a little bit earlier to be 12.9. So that means this distance here should be 12.9 minus 2, or 10.9 meters. So there's our new diagram. I should be able to find x in this diagram then. From x, I know the opposite. I know the hypotenuse. The trig ratio that uses opposite and hypotenuse is the sine ratio. So the sine of x is equal to opposite 10.9 divided by divided by hypotenuse 13.4. How do I find that? I go to my calculator. I go second function sine 10.9 divided by 13.4. Second function sine 10.9 divided by 13.4. And this will give us an angle of about 54.4 degrees. It wants it to the nearest degree. So we would say x is 54 degrees. All right. Very good. So you guys have your self-assessment sheet. You know what your assignment should be. Or if you haven't got it, you're going to get it shortly. All right. Away you go.